All right, so we are back. AP Calculus. We just got back from Yosemite. Today's date is Friday, September 13th. September 13th. If you did the math right, yes, September 11th just passed us. Today we're doing notes 2-2, Finding You. Haha, I found you.
Good job, Mr. Snow.
I make the same joke every year. Nice and
Good
easy.
Beautiful.
Except for that we were talking about the full moon and we were.
All right, Claire, what is our objective today?
The objective is finding the inner part of a wide variety of functions.
Yes, so let me teach you about houses. Houses are made out of stone. They're sometimes made out of wood. No, AP Calculus houses, you have one of 5 types. We'll add on 2 more types when we hit BC, I believe. I might be making that up. But I know that we add on a few different houses for BC calculus. But for AB, you have 5 houses. You have the general house. The general house is some function, f. And usually if I always put a coefficient in front of all these so that we know that there is a coefficient. So I'm going to say a times f. And then the function has f of something. So f of x or f of something. And I'm going to call that f of something the inner. Maybe you have a different function. Maybe you can have a function like this. I'll do a different color. Maybe you'll have a function like a times g of the inner. The main thing that you need to know is that you'll just have some random function. AP tests love to just give you f of something and make you take the derivative of it, and people freak out. They're like, is that f of something x squared? Is it square root of x? I don't know what f is. The whole point is you know how to find the derivative just because it's f.
So saying f inner is the derivative?
So whatever's inside here, it could be something. It could be like f of x squared plus 1 or something like that.
Okay.
The inner just takes the place of something. We don't know what that inner is. It will until I write it down. What does a trig house look like? Arrow from last year. It's a times.
What is a trig? Huh?
What is trig? What is a trig function?
I don't know.
S, the
Sine
of inner.
of an inner.
I'm just watching to see, right?
Or a times. We'll do a different color.
Sine.
A times cosine. What's another one?
Tangent.
Inner. Yeah, tangent. So a times tangent. I ran out of room. But yeah, tangent would be another trig. Typically, AP tests love sine and cosine. Tangent is on the AP test AB version, but it's just less common, so I'm not even going to write it.
Are you going to be able to use the SOHCAHTOA thingy?
You are not going to be using SOHCAHTOA nearly as much. You have E house. So we've done general house, trig house, E house. So that is something like A times E. But the tricky part with E house is where's the inner?
Oh, it's in the top.
It's in the power.
The X component.
So the inner is up here. I'll put parentheses around it. We'll just stay consistent. E to the power of inner. So if I'm, again, the whole point is, where is the inner? If you're looking at E house, it's in the exponent. I might try to trick you by doing E to the power of something with parentheses next to it. It's not the parentheses next to it. It's the power. And then we have log house, like a log cabin. So log house is A times natural log of the inner. I know that a lot of people pronounce this ln, and I know what you mean by that, but please say natural log, because then you sound like a very complex mathematician that knows what you're talking about.
Log natural. Like, why is it?
Oh yeah, so it's Latin. Latin is backwards.
Oh.
Logarithm naturala, or something like that. I don't know. Yeah, but most of math comes from the age of when Latin was our main language. We were educated like that. Yeah, so natural log. Will we ever have normal log? No, not in AB.
Log. Yeah.
But we will have normal log in BC calculus. You will need to know.
You saw.
Normal log, if you don't write anything, you assume it's log base 10. Natural log, you assume it's actually log base E. So these two are the same. This is the natural, or that's just your average ordinary log. So for all of us, we're doing log base E. Good question. All right, so moving on from here. Power house. This is probably the most common house that you'll ever see. It's some coefficient out front, and then you have your inner to some power. We don't know what that power is. I'm just going to call it n. But that's the hardest one also, because it's the hardest one to see, because you have to all of a sudden be like, oh wait, there's an exponent. That means I'm in powerhouse. It's the most confusing because it's just this tiny little n right here. That's the thing that means you're in powerhouse. There's no giant sine or cosine or e that gives it away. It's the fact that there's a power.
But it's also the standards.
Does this one get confused a lot for the E one?
It does not, no. Because E1, like, if it doesn't have an E, it's not E house.
Okay.
All right, so all we're doing today is identifying. inner and outer, and obviously taking the derivative of the inner. You should know how to do that. And then eventually Monday, I will be teaching you how to take the derivative of the houses that we're talking about. For now, you don't know how to take the derivative of e. You don't know how to take the derivative of log. Not until Monday, then I'm going to teach you how to do the derivative of the houses. For now, identify the house and be able to take the derivative of the inner. You know how to do the derivative of the inner because that's what we did on Monday. So let's come down here. House. What house are we in?
Powerhouse.
Powerhouse. Write it down. We're in powerhouse. What is the outer of powerhouse? So everything that's not the inner is the outer.
3.
3.
So it's going to be 3, and then we'll write the parentheses. Blunk, blunk.
3.
So the
Inner is 7.
So yeah, we'll do 3.
Power 7.
Let's do U. So U is usually what I write for the inner, just to abbreviate so we don't have to write out I-N-N-E-R each time. So the inner is going to be called U, and then to the power of 7. 3 to the power of 7.
So basically, when you're finding the outer, you just replace the inner with a variable.
Yeah, so just, and even more so, just ignore the inner.
And the inner is just what's in parentheses.
Yes. Well, not always, because look at this one. This one has no parentheses.
But that's because it's the E one, and the E one's confusing because it's, yeah.
Yeah, I mean, I can break that rule several different ways, but for now, that's a good way to think about it. And then what is the inner, or the U that we just wrote down? What is the
X
inner?
plus 1.
There it is, x plus 1. And then someone, what is the derivative of the inner? Derivative
1.
of u with respect to x is 1. Why is it 1, Gio? All the way back from Monday. Claire, help us out.
Because so to find the derivative, you only look at the ones with the variable in it, so x in it, and then you take the exponent from it and multiply it by whatever the number is in front of x. And since it's 1, it's just 1, and then you make the exponent go down 1. It's 1 and 0, so it's just 1.
So, yes, that is the technical way of doing it. The other way of doing it, Gio, is Gio. If you ever see anything x, no squared, no nothing, no powers, anything x, just look at the coefficient. What is the coefficient of x? Done. That's it. And then the derivative of a constant, Gio, is derivative of a constant. Someone else? 0. So this is really 1 plus 0 because plus 0.
Okay.
So you have to take the derivative of each of these together. So x plus 1, that turns into 1. All right, moving on. What house are we in? Shout it out.
Powerhouse. Right. Are we on the next one?
We're on the next one.
Oh.
We are now in log house.
I
was
this
not clear.
One. I like this one.
We are in log house. What is the
I like
outer?
this one.
The outer is
1/2 log.
1/2 natural log, and then we have to worry about the inner later. What is that inner? Now we're dealing with the inner. 2x. And then, Gio, use your rule that I just taught you. What is the derivative of the inner with respect to x? Take the coefficient.
2.
There it is, 2. That rule gets harder whenever you have powers, but for now, just take the coefficient. All right, and then what house are we in for the third problem?
E.
We're in E house. E house is my favorite house. It's really nice.
It's very easy.
The outer is
2E.
just E. E to the power of something. The inner is
2x.
2x. Therefore, the derivative of the inner with respect to x is
2.
easy peasy lemon squeezy. Let's move down here to talking about inner. I think that's all we have yet. We're done after this. Inner. You can have an inner. And that's what it looks like.
Oh, I get it. I think maybe.
You have 2 houses. You have a house within a house.
Yeah.
So
The
you
outer
have
house,
three
the most outer house, is called
E.
E house. So the most outer house is E house. What is the outer when I'm just talking about E house?
E.
E to the power of?
L. N. U.
We don't care about the inner.
EU.
We don't care about the inner. So the inner, just leave it U. Yeah. Now what is that U? What is the inner that we found for the house of E?
Natural log of 3.
No, natural log of u. Right.
No, 3x minus 1.
So you're right, Arrow. You're getting ahead. I'll write it out. 3x minus 1. And what I'm going to say now is we are now in another house. So we now need to say this 3x minus 1 is our new inner. In fact, that is our inner. I'm going to call that, well, I can't call it U because I already used U. So V. This is going to be my new inner. So it's my inner. V is equal to my inner. In fact, I don't even need to write that down because I have it right here. So what is my inner? So this is really natural log of V. And what is V?
3x minus 1.
Minus 1. And what is the derivative of the inner with respect to x?
3.
Gio's on it. There it is. That's all you need to be able to do for the homework. Know what house you're in. You don't even need to write down the house for the homework. That was just for the notes. Know what house you're in. Be able to write the outer, the inner. Take the derivative of the inner. Then you're done. Over and over again.
That's really cool. I
Oh.
like this one.
Are you ready for the homework? All right, go ahead and do that.